Hello everyone. In this video series, we will be discussing battery test solutions from a technical perspective. We'll also review some of the most important specs to consider when selecting parts for each socket in a battery test design. We'll start with an overview of how a typical battery test system works, and then we'll take a deeper dive into some of the functional blocks within the system. We'll discuss error sources, and why precision amplifiers are so well suited for these sockets. Finally, we'll showcase an example circuit and discuss some of the lab results we were able to achieve with it. After calibration, our hardware solution was able to achieve better than ± 125 parts per million precision in current mode, and better than ± 70 parts per million precision in voltage mode. Stay tuned for future videos where we'll discuss these results and more in greater detail. Next, we'll briefly address some important background information and common terminology. Feel free to skip to the next video in our series if you're already familiar. We'll focus on charging and discharging a single-cell lithium-ion battery. One of the simplest ways to assess the charge of such a battery is to simply measure the voltage across its terminals. This kind of battery has an upper charging limit, which we call the regulation voltage. For a LiPo, this is about 4.2 volts. The battery also has a lower discharging limit called the threshold voltage, which is about 2.8 volts depending on the battery process. Going beyond either of these limits can result in damage to the battery. While the same battery test architecture can also be used for other battery types, such as nickel metal hydride, keep in mind they will have different regulation and threshold voltages. There are three typical tests that a battery test solution may be called upon to perform. In battery formation tests, an initial charge and discharge cycle is performed on a new battery. This cycle is necessary for the battery to store energy properly, and its results are also used to sort the batteries into different grades. This test must be performed on every battery in each lot. The second test, which is typically only performed on a few devices from each lot, is the loop and feature test, which consists of repeated charge and discharge cycles to verify the battery life and reliability are within the specified tolerance. Finally, functional testing may be performed to double-check that each battery works properly before packaging, and to get the battery voltage to the proper level for shipping or storage. Whether we are charging or discharging the battery, at a given time the battery test system is in one of two modes: constant current mode, CC, or constant voltage mode, CV. As the names imply, in constant current mode we are charging or discharging at a fixed current, and the battery voltage shifts as it is charged or discharged. Whereas in constant voltage mode, we hold the battery voltage at a fixed level, usually the regulation or threshold voltage, and the current rolls off to 0 milliamps. This slide shows a block diagram for a battery test solution with support for both charge and discharge modes, with monitoring through an ADC and control via a DAC. Note that because this system supports both charge and discharge, it features three control loops: one for the constant current mode, one to force CV high mode as the battery voltage approaches the regulation voltage, and one to force CV low mode as the battery voltage approaches the threshold voltage. We will refer to this set of control loops as the battery cell test unit. In order to monitor the charge or discharge current, as well as the battery voltage, a second unit called the precision monitoring unit is also needed. The precision of the amplifiers in both of these units will determine the accuracy of the battery tester. A driver unit is also required to source and sync the charge or discharge current. This is often a switching power supply with an AC-DC converter or a buck-boost converter, but a power amplifier can also be used to reduce the system cost and complexity for lower current applications. Thank you for your time. Please visit ti.com for more information on battery test systems and other useful resources.